FTP, the File Transfer Protocol. This is the second application layer protocol we're learning here. So, see if you can identify what is the communication model, what is the structure between all these entities involved, and what is the underlying transport layer service, and what are the message types, syntax, semantics, and how are these messages exchanged. Pay attention to these. So first of all, what is the communication model? You see here, client server. Client is always the side initiating transfer. So over here, this side. And server is always the one that's far away, so over here. All right. So what you see here is FTP is to provide transferring of files to and from the remote host. Server here is essentially allowing the users or the client access to the hard disk here. Okay, so it's a little bit like Dropbox. Okay. So a distributed file system in a way. Good. Now, file can go this way as well as this way. So you see here, it's bi-directional. Good. The protocol is defining this RFC. The number is only 3 digits. You see that this is one of the earliest internet protocols. The server there is sitting on port 21, another well-known default port number. So whenever the client needs to initiate communication, it goes to port 21, where the FTP server will be sitting on. And by the way, 21 is also the port number that probably confuses SSH's port number on. All right, so let's take a closer look at the message exchange. All right, so FTP clients contact FTP server at port 21, this we know, and specifying TCP as the transport protocol. So FTP there uses TCP just like HTTP as the underlying transport layer service. And then the client will try to authorize itself into the server over a control connection. So what I'm depicting here is also what's going on here. The client will establish a control connection towards port 21, okay, at the remote host. So messages saying, I want to log in, here's my password, will go on this connection. After the client logs in, it's going to browse through the directories, okay, in the remote hard disk over here. So the commands changing the directories around is going to also be sent over the control connection. When the server receives a command for a file transfer, okay, so command for file transfer also travel this way as it's also a command, so it goes on the control connection. But the server now, okay, will open a TCP data connection going back this way. Okay, so that is depicted here. The data connection running on port 20. Okay. After transferring a file, the server is going to close the data connection while this one remains on. If the server needs to send another file, it would start yet another TCP connection and send the file over there. Okay. So such separation of control and data-based content on different channels, okay, in communication, we call it the out-of-band communication. If you think a little bit more in HTTP, there are two messages, right? HTTP request, HTTP response. Yeah, which one is data? Which one is control? No, in fact, each of these messages are both control and data. In HTTP request, we do have command, right? Get, post, head. But in HTTP response, we also have the status line. So these are obviously control. But in both messages, we also have the body entity. If you use a post command in HTTP request, you might be sending also some data up to the server. And very classic web response, the entity body contains the web object. So in HTTP, communication is in band. One word, in band. All right. Data and control messages are bundled together and going on just one connection. FTP, very weird, out-of-band communication. Another thing that FTP differs from HTTP is this. HTTP being stateless, but FTP is stateful. So FTP server here actually store information about the client's previous visit, including where the client at in the directory structure before the client logged out. Okay, so next time when the client wants to log in, the server will take him directly to whichever directory the client left. So the client can continue working on, downloading files or uploading file in that space. Similarly, if you log in as a client, you might get a message from the server saying, oh, you logged in previously at a certain day and certain time. Okay. So this is sometimes a nice thing to do because you might want to know if there are unauthorized login and authenticated login, meaning someone stole your password and then use it to log into the FTP server. Next are just a few examples of the messages being exchanged between the FTP client and server. So these simple comments are messages the client sent to the server. And server typically return these return codes, right? So very much like the HTTP request, the control part sends comments and necessary information to help the command to be executed at the server side. And then the server returns certain code, phrases, and explaining of the code and the phrases. All right, let's look at the example. Oh, and by the way, again, in FTP, messages are in ASCII text. All right. Data, however, on the data connection could be in bytecode. All right. So control connection there is always sending ASCII text messages. And control connection there is also allowing the server to send back a status code. Okay? So these and these all on the control connection. Only the data on the data connection. So let's begin. User, capital user, space, username. Hey, you guess, this must be a user trying to log in and providing the username. So this is a variable, so comment, argument. And this is going to be sent through the control connection to the server. Server check. If the user does have an account on the server, then this is what the server sends back. 331, username, okay. And server asks, could you send me the password? So, hey, a hacker might figure out the username, but not necessarily the password. So, client here sends pass, again, capital, space, password, over to the server. And then the server can perform the rest of the authentication. So you see, capital, PASS, capital, USER, these are special words, okay? In the comment messages. All right. So each followed by an argument. List. This is a special command. No argument required. What it does is to return the list of files, okay, in the remote directory. So upon receiving list at the server, server sends, okay, here are the files in the directory. Retrieve. RETR capital, space, file name. This is now officially to ask for a file from the server. Retrieves files. The other way around, if we want to store a file, upload the file to the server. Then store, capital, file name. Now, here are some status code and phrases the server might respond. So, 125, data connection already open, transfer starting. So this might be the server responding to a retrieve command, okay, setting up a data connection, and then next bytes are going to come. Or Server might find that, hey, there's not enough socket to open, or there's not enough bandwidth can open data connection message might be going back. 452, error writing files. Oh, okay, so this is this case. If the client wants to put the file onto the server, and if there's not enough disk space, or if the client doesn't have the access right, the readable access right, the writable access right, then the client gets this message, 452. Okay, so that's FTP. We see again, an application layer protocol defines communication model. Is it client server, P2P, or hybrid? An application layer protocol defines also what is the network structure. In both HTTP and FTP, it started off very simple, one client, one server. But you see earlier in HTTP, it kind of grows a little bit, having these proxy servers in the middle, helping with the transfer. In every one of these application layer protocols, we also need to define what are the messages to be exchanged and the order they exchange. So we see here examples of messages defined for FTP and how they're exchanged, okay, in the previous slide. Okay, through the control channel, yeah, logging messages, checking directory messages. So this is FTP.